Welcome back, everybody. Today we're going to wrap up our chapter on conditionals and logic by talking about something called the equals method. So let's get going with that. Now, to give you an idea of why an equals method is necessary here, let's take a look at a simple class, a point class, something we've dealt with a few times in the past before, where basically a point object stores a int for x and an int for y, just for an x and y coordinate. And to construct a point, I have the constructor that accepts an x and a y, and it assigns the x and y values. Dot, dot, dot. This class will probably have some other stuff happening. But for now, all we really need are the instance variables and the constructor. And let's see what happens when I try to compare different point objects to one another. So let's say I make a point P1 and set its coordinates to 7 and 13. And then let's make a second point P2 and set its coordinates also to 7 and 13. So essentially we're making the same point twice. And then we'll make a third point P3 and we'll just say that's equal to P1, so we'll basically copy the address. Let's take a look at what happens when you evaluate some Boolean expressions. P1 equals P2 and then P1 equals P3. When I run this code, P1 equals P2 actually is going to print off false. Now, why is that? That doesn't really make sense. We're talking about the same point essentially, both with x coordinates of 7 and y coordinates of 13, but I'm going to say Java is going to give us a false when we evaluate this expression. Now when I do the second expression, P1 equals P3, Java is going to give me a true. So what hopefully you're seeing here is that this equal comparison operator doesn't quite work the way we'd want it to when we're comparing objects. So what just happened there? Now the way the equal operator works is it compares the value stored in the reference variable. Now in the case of primitive values, and we're storing numbers like 5 or Boolean expressions like true or false, that's okay. We want to compare those two and see if they're the same. But in the case of objects, remember what's being stored at the reference is a memory address for the object. Not any actual information for the object itself, it's storing the memory address. So coming back to the question we just looked at, when I run this code, P1 gets new point 713, what's happening here is P1 is going to store a location of a point object with the x value set equal to 7 and the y value equal to 13. And what actually gets stored in this P1 space here is the address of this. We could say it's at 1234 Fake Java Street. And we've said in the past that P1, what it stores is the pointer to that object. So when I do the second line of code, point P2 gets new point 713. Same thing happens. P2 is going to store a memory address for a different point object with the same x and y values, but at a different address. We'll say 5678 Fake Java Lane. Alright, and when I run this comparison here, P1 equals P2, what Java is actually comparing is what's stored in these memory addresses, and they're not the same. Now the reason this second comparison does work though and gives me the true is when I say P1 gets P3, what we're doing is we're creating a P3 reference which is getting assigned the same address as P1, 1234 Fake Java Street. So what we could say is that they're pointing to the same object. That's why when I run this comparison, Java says, yep, that's true. They're both storing the 1234. Alright, so that issue we just ran into brings us to the idea of an equals method, because it would be nice to compare two objects and say they're equal if they hold the same data. For example, I can think of a lot of applications where if we have 2 points stored at 2 different locations, but if they have the same x and y values, I'd probably want to say those points are equal. Okay, so that's where the equals method comes into play. Now, we've talked about this idea a little bit. In Java, all classes are subclass of the master object class, and all classes inherit certain methods from the object class. We'll worry more about inheritance in chapter 10, chapter 9, something like that. But this is the same idea as the toString method. By default, all objects, when I go to print them, are going to print off the address, and we can override the toString method to get it to print the way we want it to print. Same thing with the equals method. Okay, by default, it compares the addresses, but just like with the toString method, we'll be able to override it to compare whatever we want for a specific application. Okay, so you can override these methods to make them specific to your class, such as a point class or whatever class we're talking about. So again, what we just mentioned a second ago, by default, the equals method tests the quality of the two object references, okay, if they have the same address, and you can, we'll say in quotes, and we'll explain in a second, override the equals method to make it test the quality of two objects' contents based on whatever criteria you're looking at. So let's look at what this could look like for our point class. So again, a point stores an x and y value, and we'd want to say if 2 points are equal if they have the same x's and y's. Well, that's what we'll do here. We'll make a method. We'll override the equals method. We'll say public Boolean, so returning true or false, equals, and then we're going to pass into it another point. And then we'll return if x, as in this object's x, is the same as the other object's x, and this object's y is the same as the other object's y. Okay, so by creating that as our equals method, any two objects that have the same x and y's are going to come out equal to each other. Okay, that would evaluate to true when we use the dot equals method. All right, now quick note, I did the override the equals method in air quotes because technically what we just did, we didn't actually override it. Okay, to actually override the equals method for an object and use the override keyword here, your method signature has to be public Boolean equals, and then it has to accept an object called O. Okay, so it has to take in an object parameter, so basically any type of object. Okay, and then to actually make our equals method work, the first thing we'd have to do within our method is we'd have to make a new point. Okay, we'll call it other, and essentially just like we can cast a int as a double or a double as an int, we need to cast this object as a point object. Okay, so we'd be casting here. We're casting O as a point. So in other words, we're taking the object and casting it as a point, and then we can run our kind of comparisons of the x's and the y's the same way we did before. You don't need to worry about doing this, and actually there probably for practical purposes be a few more lines of code in the beginning to kind of test and make sure that our object is of the right type before we cast it. Okay, overriding the equals method isn't something you need for the AP exam. It is a little confusing. Okay, we're just going to be doing some kind of fake overriding for purposes for our class, but if we want to, we could, and it will make more sense as we get into inheritance and object hierarchies way later in the course. So from now, don't worry about this. This is the technical way to do it, but we're kind of sort of accomplishing the same thing with our override, the simpler version. All right, so let's see how our new override method works. Let's make 2 point objects, P1 and P2, with x set to 7 and y set to 13. And then we'll also make a third point object by, again, copying the address of P1. And when I run this code, P1.equals P2 evaluates to true, because again, the way we designed our equals method, and we can make it any way we want, but the way we designed this one is to evaluate to true when the x's and y's are the same. Okay, the second one also evaluates the true because since I just copied the address, since they're both pointing at the same object, we're going to have the same X and Y's there also. So next, let's talk about how this equals operator works with strings. Okay, because remember, strings are objects, so it should work the same. Well, just like with objects, the equal compares the string reference, the memory address of the actual string objects. Okay, now the trick is with strings, sometimes it works the way you'd like it to. Sometimes it will compare the actual strings. So if I go string stir1 gets hello and string stir2 gets hello, and I compare that, stir1 equal stir2, that is going to evaluate to true, even though these are two different strings. And sometimes it doesn't work the way we'd want it to work. If I go string stir3 gets new string by, so as in calling this string constructor, and string stir4 gets the same thing, new string by, and I compare these, it evaluates the false. Okay, so the big thing here is that this equals doesn't always work the way we'd think it would. It doesn't always compare the actual characters in those strings. That's why you should never compare strings with the equals. You should always use the dot equals method. All right, so real quick, let's take a look at why sometimes the equal operator does work for strings. Okay, so let's say I write the code string stir1 gets, let's say hi. Okay, when I run that code, what does Java do? Java creates a memory spot for the reference variable stir1, and it's going to hold on to the address of a string object. And remember, objects live off in the heap part of the memory. However, it's a little more complicated with strings. Strings occupy a special part of the heap called the string pool. So when I create this within the heap, within the string pool, we're going to get a string object that holds on to hi. Let's say it lives at 1234 fake Java street. All right, and 1234 is going to point off to that. Okay, here's the trick. When I go string stir2 gets hi, what's going to happen is we just made a reference variable called stir2. It's going to store the address of a string holding on to hi. Now, before Java creates a new string, the first thing it does is it searches the string pool for an identical string. In this case, we already have a hi, meaning that stir2 is just going to hold on to 1234 and point to the same string. Okay, so why does Java do that? I guess I'm not quite sure. I guess the reason it does work for strings are immutable. If I want to add to either string 1 or string 2, it would just create a completely different string. So it's okay they're pointing to the same thing. Okay, because if I change one, it doesn't actually change it. It makes a whole new string. Okay, so again, usually it works the way we'd want it to work, unless we have something like this. If we go string stir3 gets new string, so calling new string constructor. When I call this new constructor, what that's going to do is force the creation of a new string. So now we have two strings holding on to hi. Okay, so that's why the equals method won't work when we call that new string constructor. Okay, if this is confusing for you, if this is something you really don't want to have to think about as you're writing code, I'd say good. I don't want to have to think about this either. That is why we're not going to use the equals operator. We'll use the dot equals method. So let's take a look at that equals method in action with strings. Okay, the string class's equals method compares if the actual characters contained in the string are identical, which if we think about strings, that's probably the way we want to compare equality, if they have the same characters, the same letters. So here if we go string stir1 gets wow, and string stir2 gets new string wow. Okay, so calling that new string constructor, when I use the dot equals, it will evaluate to true. Okay, whereas with the equals, it wouldn't have. Okay, or if I compare stir1 dot equals to just the literal wow, I'll get true as well, true in both cases, because we're talking about the same characters, the same wows there. Okay, I guess after all that, moral of the story is just like with objects, okay, because strings are objects, always use the equals method to compare strings. All right, and the last thing we're going to talk about today is the strings Compareto method. And essentially the Compareto method is going to function as a greater than or less than comparison for strings. Now, why would we want to compare greater than or less than for strings? Well, essentially that's going to allow us to compare alphabetical orders. Okay, so the string Compareto method compares the letters in a string objects. Okay, the difference in the ASCII, okay, so as in the character codes of the first two letters that do not match, is returned. Okay, what ASCII is, in your notes I believe I have an ASCII table there for you. Basically it assigns every character an actual numerical value. So J is given a numerical value, a parenthesis is given a numerical value, and that allows for comparisons. So let's make a couple of strings. Let's make stir1 have cat, stir2 get frog, and stir3 get cat. When I run this code, stir1.compareto stir2, I'll get returned a -3, and the reason for that is F is 3 letters away from C. Okay, so C, D, E, F, yep, 3 away. So meaning that if the string that I call this on comes before the string that we pass in as the parameter, I'll get a negative value return, and that value is going to be the difference in letters, okay, of the first letter that doesn't match up. Okay, if I flip that order around and go stir2.compareto stir1, so in other words I go frog compared to cat, I will get the +3, okay, because frog comes 3 after cat. And then last thing, if I pass in the same string to the Compareto, stir1.compareto stir3, in this case I get a 0, they match, there is no difference. Okay, so one's not bigger than the other, there's kind of a 0 difference between the two of them. All right, typically when we write programs, we're not so much worried about what the actual positive or negative values are, but if they are positive or negative. Okay, so in other words, does the string it's called on come before if it's negative or after if it's positive? Okay, and when I think of AP test questions, usually they don't ask what's the specific value, just in general, is it positive, is it negative, or is it 0? All right, so there you go. There is the equals method for comparing objects, including strings. Okay, and then also the Compareto method for strings specifically. Can be some tricky stuff to work with when you get going, but like everything so far, you're going to see it over and over again as we go through the rest of the semester, through the rest of the course, so you'll get good with it. So start working on some programs, okay, start cranking through the homework, and like usual, if you get stuck somewhere, let us know. We'll help you out.